I'm recording. Very well. Oh, I need to share. Very well. This is Stephen Smith. This is part 2 of the scheduled recording, 9/22/2017, Collin College. This is ITSE 2309, which is database. We are now in Module 6. Module 6 is Chapter 4 in the textbook. So I give you the reading assignment, and the reading assignment is really serious. I tend to approach it a little bit differently. But what we're going to be talking about in this module is, instead of just retrieving data from one table, we're going to be retrieving data from related tables. It makes no sense at all to join, well, I don't know about no sense at all, but it makes no sense at all for right now anyway, to join two tables that are not related by a foreign key primary key. So foreign keys, as far as we're concerned, always reference a primary key. That might not be true in the always sense, but it always does here. Foreign keys reference a primary key. Now, what I'm interested in is pairs of records that share the same primary key, foreign key relationship. So if I want to select all the parents with their children, so show me the parent-child pairs, okay? I will use what we call the table join to do that. Now, I approach a table join a little bit differently than the textbook. So I'm using an older syntax here, and then I'm going to promote us to the newer one here as soon as I get it done. So I have a parent. My parent table has one field, PID, parent ID. Recording okay? Okay. So parent, I guess I can point with the mouse, has one field, a primary key. That's it. Okay. Then, and there's a constraint, parent, primary key. So here I'm not being lazy with the constraints. I'm doing them the way I'm supposed to do them. Child, I have a child's table. A child has a child ID, CID. And here's one. Notice that the PID does not match the first letter, so that tells us, so the child primary key, constraint, foreign key, references parent ID. How many parents does a child have? At most, one. Can a child have 0 parents? Does this table allow orphans? I'm shaking my head, yes. Why does this table allow orphans? How can I tell? Right. And a lot of you got little nastygrams from me on the pets, owners and pets. I said a pet has to have exactly one owner, not 0 owners. We don't have any orphans. We don't have any homeless kitty cats here, not in this database. Everyone has to have an owner. Okay. So this one would allow, because if I did not want to allow orphans, I would have to constrain the PID in the child table to not null. There's nothing that says a foreign key cannot be null. A primary key cannot be null. A foreign key definitely can be. Okay, so I'm going to insert into the parent some values, A, B, and C. Insert into the child X, Y, and Z. X is a child of A. Y is a child of A. Z is a child of B. So we say that we see that A has 2 children, B has 1, C has no children. Okay. Now, in the next line, and there we talk about that. Okay, I talk here about blocking that orphan bit, but I didn't. Let's see where I'm going here. Consider the following table. Now, remember last time I gave you the vendors table and I put it together and I said vendors dot vendor name, vendors dot vendor phone. And I said, you don't have to do that yet. And I put yet in bold. Now you have to do that. So I'm going to select, look at this one, what's highlighted up there on the screen, select parent.pid, child.pid. If I just say PID, it's not going to work. Why? Because the system does not know which one I want. Okay? So I have to say I want the parent ID, or the child, parent ID. Now for the CID, that's only in one table. Therefore, I can get away with just saying CID. Okay. Now, I'm saying here, I'm saying from parent, comma, child. That is a table join. That says take both of those tables and put them in the output. Are you with me? Now, I want you to look at the output of this. Notice the rows I got. I numbered them for you. 1, 2, 3. I didn't put any order by on there, so if you actually ran it, you might not get them in that order. But those are the 9 rows you would get. 9 rows. Notice that I got parent A in as a primary key, parent A as a foreign key in row 1 has child X. In row 2, I have parent key A, foreign key A has child Y. Are you guys watching? Are you guys, you're following on Zoom, okay. Row 3, the primary key is A, the foreign key is B. What did I get when I put the 2 tables together in the select state, in the from line, from parent, comma, child? What did I get? Remember, I had 3 parent rows and 3 child rows. Notice that I got 9 rows total in my output. What did I get? Explain that to me. All of the combinations. Every combination it could make. So I noticed that I got A, parent key A, combined with every possible record in the child. Parent key B, I 1, 2, 3 of those, combined with every possible child key, and parent key C, combined with every possible child key. Okay, this is called a Cartesian product, and it's useful in many ways. But I don't want all of those rows. I want to see parent and child relationships. I don't want to see everybody else. Which of the rows, and the highlighting up there is important, which of those rows am I really interested in? Where the primary key and the foreign key are equal. For example, I'm interested in row 1, row 2, and row 6. The rest of them are just there, but I don't need them. Okay. Questions? So I need to filter that out, and my where clause then is going to be, I think you can find it. Scroll down. Notice that I have aliased my tables in the from. I did not have to do that. I could have left them named parent and child, but I aliased the parent as P, child's table as C. Now let's move on. So it's called a cross join or a Cartesian join, and it's discussed on page 148 and 149. They start with a different, the book starts this in a different way. Now, I'm going to add one more. I'm going to add the where. The order by, I don't really care as much about. I just want it to be consistent. The where clause, notice the where clause, I only want to see the rows where the parent PID is equal to the child PID. In other words, I should just see 1, row 2, and row 6, excuse me, pardon me, 1, 2, and 6 in the output. So when I put in that where clause, I get that. So parent A has child X, parent A has child Y, parent B has child Z. What about parent C? Didn't have a child. Therefore, he or she just disappears? The answer is yes. That is a property of this type of a join. Okay? This type of a join is called an inner join, and we're going to see it in a different syntax in a minute. This is the old syntax. Okay? But I learned this using the old syntax. And so I treat that one first because I think students see it a little bit better if I just say from parent P, comma, from parent, comma, child. And I alias the tables because the reason I alias the tables, I don't like typing. I don't have to alias the tables. I could say where parent.pid equals child.pid. Yeah, it's just a lot easier if you'll alias them. Only reason I do that is to reduce the amount of keys I have to hit. Questions? What we have here is known as the inner join. The syntax I am using is old. In fact, it's been considered obsolete since 1992. However, it is still in use. People still do it this way. We're going to talk about that. A very important property of the inner join. This is a test question, or a to be determined. Records that do not participate in the relationship. In other words, parents without children, children without parents, will not be returned by an inner join because the inner join is about the relationship. If they don't participate in the relationship, they will not be returned by the inner join. Inner join is the simplest of the joins. Okay, follows foreign key, primary keys. It's used to follow foreign key, primary key pairs. Does it have to be a foreign key, primary key? Doesn't make a whole lot of sense if it isn't. It does not make any sense to ask, I want everybody from the one class whose shoe size equals the IQ of the other subclass. It doesn't make any sense. If it's not a relationship, foreign key, primary key, it doesn't make much sense to talk about a join. It might, but the relationship has to exist. Okay, I'm going to move on here. It says try it. Write a query demonstrating an inner join that returns all vendor name, invoice number pairs. Vendors is the parent, invoices is the child. Okay. So, and that's a good little exercise. I want the vendor names and the invoice numbers. What is the foreign key, primary key to the vendors and the invoices table? Does it have a, what is the primary key? Vendors. What is the primary key of vendors? Can you see it? What is it? Well, how can I find out? I'm going to go over to vendors, and I can see the primary key. I'm pointing to it with my mouse over there. What is the primary key? Oh, come on, you can see it. I'm pointing to it. Okay. Can you just not, you can't see it? Okay. Yes, it's vendor ID. Primary key of the vendors table is the vendor ID. Let's go look at the invoices table. Do you see vendor ID in the invoices table? Notice it says it's a foreign key. Okay, so what is the where clause on this? I want to select the, let's see, vendor name, invoice number from vendors, and you can alias it as V, invoices, where, here's where the rubber meets the road. What is the where? Where? Invoices.vendor.id is equal to vendors.vendor.id, and I personally would alias those as V and I. Questions? I'm going to move on. Do go back and do that exercise. There's the slides. I don't think I'm going to use the slides today. I might use them next time. Okay. Here is where the rubber meets the road. Here is what I was expecting you to write. There are other ways to write it. Notice that I aliased it as V and I. It's only aliased in this select statement. It just keeps me from having to type it again. Questions? Follow the primary key to the foreign key. There is no particular order to which one you do first. I typically have, I didn't do it in this case. I will typically put my primary key on the left of the where clause, from primary key to where the primary key is equal to the foreign key, but there's no hard and fast rule that says you have to do it that way, because equal works just as well either way. Equal means is the same thing. Doesn't matter. It's okay. Maybe some variation on what you name them or whether you alias them or didn't. Now, let's move ahead to the new syntax. we typically use the new syntax. That syntax that we just used right there is the old pre-1992, certainly pre-Y2K syntax. It's considered obsolete, but it still works. It still works because it has to, and it will continue to work. So if you learn, I want you to learn to do it both ways. Here's the new syntax. Okay. In this case, I am aliasing on the select line. I do not have to alias on the select line. I just did. So select p.pid. I'm aliasing on the from line for sure. So parent as p. Select p.pid. Let me see if I can blow this up a little bit. This is worth. Yes, I can. Okay, working right here. Okay, this is the new syntax. Select p.pid from the parent table. Boy, okay, how do I know it's the parent table? Because the parent table is aliased on the from line. I have to use the alias. I cannot say parent.pid if I have aliased the parent table. The as is irrelevant. C.pid as foreign key, so I gave it another name so we can tell them apart. And then CID, didn't alias that one. From, parent as P. Inner join, child as C. On, okay, here is the where clause. Everything that is in the old syntax is still in the new syntax. All of the information from the old syntax is in the new syntax. There's nothing different about it. The only difference in it is that some people think this one is easier to read. Do you think it's easier to read? If you think so, fine. We will typically use this one unless I tell you to use the old syntax. The textbook calls the old syntax the implicit join, and this one is the explicit join. Notice it's from parent, and instead of the comma, they have the word inner join. And then instead of the from, they put on the link. Order buys the same. Okay. They do exactly the same thing. Exactly the same query as the one titled Exhibit A on the previous page. The textbook's author chosen not to alias the table names. This is optional in some, I'm just reading it to you. Okay, you don't have to alias the table names, but you do have to use the table names anytime that the field names are the same. I told you that you should keep the field names, the foreign key, named the same as the primary key. I believe this is a good idea and a good thing to try to do. Can't always, but I try to do it. Some people say, well, gee, if they weren't named the same, I wouldn't have to fully qualify it with the table name. So I wouldn't need to alias the tables. I wouldn't have to say parent.pid is equal to the child.pid. What do you think? I like them to be named the same. It makes it easier for me to see it. You may have different opinions. Okay, the textbook will also do something that I don't teach, and so I'm going to tell you not to do it. the textbook drops the word inner sometimes. And sometimes people will do that. They will just say join instead of inner join. Because if you have a join and all you say is inner join, if you drop the word inner, the only thing that could come before the word join would have been inner. So it will always work. But I'm going to get mad if you do that. When I get mad, you know what I do, don't you? I get even. No, seriously, I think it is good practice to use the full syntax. Use the as, even though you could do it without it, and use the word inner, even though you can do it without it. Later, you get out of this class and you're writing your own SQL, write it the way you want to. If you say join, it defaults to inner join. And we're going to use the full syntax, yada, yada. Try it. So this one, I want you to do the same thing. I want you to write the same query using the full syntax. And I give that to you. Here is the join. Notice that the inner join does not have a where clause required. If you use the old style of the inner join, you have to have a where clause. So the join condition goes in the where clause in the old style, so you always have it. The new style does not have to have a where. The old style does. So where? Well, I don't know where. Do you want to see only the children where the parents live in Muskogee, Oklahoma? Do you want to see parents and children where the child is less than 10 years old, or something like that? So the where clause can go in there. The where clause can apply to either table, and it will apply to the relationship. So this is why I like it when my field names are unique in my database, in my schema. I can't always get that, but the only time I'm going to have two identical field names is that when they are a foreign key, primary key relationship. Otherwise, I will prepend enough of the table name to the field name to make it unique. Now, when I look at it in a where clause, and I have several tables in there, all I need to see is that field name, and I know exactly from which table they're taking it, unless it's a foreign key or a primary key. In that case, I have to specify. But hey, isn't the foreign key and the primary key always, virtually always, almost 99.99999% of the time going to be the same? Yes, they will, because that's how they get in the relationship, when they're the same. So does it really matter which one I'm looking at, whether I say I want to see the foreign key or the primary key? No, it doesn't, but you still have to specify it, because it would be equivocal. Only wanted to show rows where the vendor state was California. It needs to have a where. It might have an order by. It might have other clauses in there that we're going to get to later. Okay. Mm-hmm. If you have field names that are identical. Now, I do not, if I can, I will never have field names that are the same in more than one table. So if I tell you a field name, it is unique to the table, except when it is a foreign key primary key. So the only time I will have a duplicate name in two tables, it's a foreign key relationship. In that case, you no longer have to put the table name. But if I have two tables, both tables use the field name, N-A-M-E, bad practice. Then if I want to see name, I have to specify which table I want to see it from. But if I say P name or O name, C name, whatever, as I do, so I always prepend some part of the table such that when I see that field name anywhere, I know exactly what table it came from. Let's see, what do I have in here? We're going to skip I'm going to skip over some stuff, 128, 129, 130, and 131, as applying exclusively to SQL Server. If you're wanting to learn about SQL Server, that's not. I'm not telling you not to read them. I'm just saying that I'm trying to stick with SQL. Sometimes I'm going to probably end with this one. What time are we? Yeah, this will be my last topic. Sometimes it is interesting sometimes it will be necessary to join a table with itself. That happens. You say, yes, I'm sorry, what is your name? Ming? Ming, you're saying, does that mean that you understand what I'm talking about? Okay, for example, when would I join a table with itself? I would have a table join vendors, comma, vendors. Now, in that case, I would have to alias the tables. When might I do that? Okay. Now, what about a relationship, employees, and the employee has a supervisor? All employees have a supervisor. Tell me about a supervisor. Is a supervisor an employee? Okay, in most cases, I would say yes. And in my example, it is. So the supervisor would also be in the employees table. So I would have a foreign key in the employees table that would reference the parent in the employees table. So Joe might be my supervisor. So my name's Stephen, name Stephen, and other information. Supervisor Joe references the employee ID of the same table. Yes, a foreign key can reference the table it is in. Now that's interesting. Okay. Tell me some things about that foreign key referencing itself. Can I have orphans? But if I can't have orphans, how do I ever get the first one in there? Which came first, the supervisor or the employee? If every employee must have a supervisor and that supervisor must be in the table, how do I get the first one in? What? Okay, but they have to have a supervisor. And the supervisor has to be in the table before you can put the employee in the table. But there isn't anybody in the table. How do I put the first one in? I could, but I'll never be able to get this if I have that constraint in there, where one, it can't be null, and two, the foreign key is in there. I'm going to have to take one of those constraints off. And there is a way with just a simple command. It's an alter table, disable the constraint. Because I know its name, it's got a name that's unique. Alter the table, disable the constraint. Now I put the first one in, the CEO, and I make him, he supervises himself. I can't put a record in that supervises himself with a foreign key constraint. I can put him in null and then update it to supervise himself. That I can do. But I can't insert a row with a foreign key referencing itself, because that it checks first to see, does that row exist first. Then it says, okay, put it in, and so it'll fail. But if I put it in, I can say not null. I can also disable the foreign key constraint. We're going to talk about disabling constraints later in more detail. If you disable a constraint and you put invalid data into the database, by default, the database will not check the data that you put in. So you can get invalid data in there. So it's kind of a dangerous thing to do. Yeah, I would, if I were, I don't like disabling foreign key constraints because I don't know that somebody's not going to put some bad data in there. I will usually allow nulls and then just put it in there with a null foreign key and then make Joe supervise Bob and Bob supervise Joe or whatever. I don't know what I'm going to do there. Textbook's example is okay. Find vendor names that share a city in common with other vendors. Okay, so I want to find pairs of vendors that live in the same city. Okay. That's a common thing to do. Now think about it. I've got vendor Stephen and vendor Donna, both live in the same city, and vendor Ming, and we all live in the same city. We live in, what's this, Frisco. Okay. So Stephen Ming is a pair. Stephen Ming is a pair. Stephen Donna is a pair. Donna Ming is a pair. Ming Stephen is a pair. Donna Stephen is a pair. And some other way there. One other question. Does Stephen live in the same city as Stephen? Stephen Stephen is a pair. Ming Ming is a pair. Donna Donna is a pair. So that's kind of a strange thing. Now, with the where clause, you can take those where they're the same. You can take that out. You can say where the primary key of one does not equal the primary key of the other one. So I can get rid of the duplicate where I live in the same city as me. But that is a very real thing. You get the harder one to get rid of is Stephen Donna and Donna Stephen. That's a little harder. You can do it with some sorting and select distinct. Okay, so there comes a time when you would join a table with itself. Here's the one that I do. EID is the primary key. There's other fields in here. Supervisor's ID, references EID. Notice that my foreign key is SID. My primary key is EID. I cannot have them named the same because they're in the same table. Here's one where I have to have them named differently. So select E1 SID as super, E2 SID as the person who's employed. Now notice that I have, here is the from employees as E1. I must, if I have a self join, I must alias both of the tables. So I have E1 inner join employees as E2 on E1 SID is equal to E2 EID. No particular which one, E1 has to be SID, that you can kind of mix these and match these, and you'll get the same result set. Almost always, a table join is almost always following a foreign key to a primary key parent. I say it's not, almost always means, well, almost. The example with people who live in the same city is one where it isn't. you can look at that example in the book. I like this one better because here we have a clear foreign key that is referencing the table. So I can have a self-referencing foreign key, and that, in fact, happens a lot. Questions? We're going to have more on this chapter. If there are no questions, I'm going to end the recording. I'm going to stop the recording now, but I'm going to leave the audio on.